Lesson 3, Graphs of Periodic Functions. So what we're going to be dealing with now is sine functions and cosine functions. They're very similar. So we're starting with sine functions. So the first things you need to learn are each of these definitions. So for the first one is period. So what a period means is how long it takes for one full cycle. So a sine function always starts down, reaches a maximum, goes down, then to a minimum, and then completes. So right here would be the end of one cycle, and right here would be the start of one cycle. So for this graph, our cycle would be 360 degrees or 2 pi. So that would be our period length. X-intercepts, there will be multiple x-intercepts throughout it. So when we have this graph right here for y equals sine x, it's every 180 degrees. But that can change because graphs can be manipulated. But for y equals sine x, every 180 degrees. You will only have one y-intercept. For this graph, it's at 0. It can be raised and lowered depending on what your midline is. So your midline is right here. It's where you could split the graph in half. And the way that we find that is you take your maximum point and you subtract you add your minimum point and divide by 2 because it's halfway between those points. So the midline also determines where our start and finish is as well. The amplitude is this distance right here, how far it goes to go up to your maximum or down to your minimum. For a normal y equals sine x graph, the amplitude is 1. The domain will be xer, or in however long it's telling you to go. And the range will always be between your maximum and minimum points. Alright, example 1. For the following graph, describe the range, equation of the midline, amplitude, and period, y-intercepts and x-intercepts for the domain x such that 0 is less than x, which is less than 720 degrees. So we're looking between 0 and 720. So first we're going to find all the information we need. So let's find the maximum and the minimum. So our maximum point is right here at 7. And our minimum is right here at -3. So our midline, find the midline next. You go 7 plus -3 and divide it by 2. 7 minus 3 is 4, over 2 is 2. So right here, you can draw it in. Don't draw it too dark because it's not really part of the graph. But this is our midline. And drawing it in can help you see the sine function a little bit better. Because if we were to look at it now, it starts here, goes up to the top, hits the midline, down to the bottom, and ends here. So that is one complete cycle. So our period length is from the start to the stop, which is 180 degrees. This one is pretty easy to see. Another way you can check is you can look from the maximum to the maximum or from the minimum to the minimum, all of which will make 180 degrees. Okay, our y-intercept is 2. And notice that this is the same as our midline. So because it hasn't been moved left and right, our y-intercept will be equal to our midline. There's multiple x-intercepts. We're not going to find them all. That's not necessary. Our domain is already right here. So domain x such that 0 is less than or equal to x less than or equal to 720, xer. And our range is y such that. Now we do our minimum is less than or equal to y, less than or equal to maximum. And our minimum is -3, and our maximum is 7. So there's all the information for this, except for the amplitude. I missed that one. So to find your amplitude, we want to find the distance between the max and the min and the midline. So what we could do is we take our max and we subtract the midline, and it's 5. Or you can take your minimum and subtract your amplitude, which is -5, which makes sense because you'd be going down 5. So our amplitude is 5. Now we're going to look at cosine functions. So a cosine function is the same as a sine function. It's the same shape. It's just been moved. So rather than starting down, it starts up at your maximum, goes to your midline, then to your minimum, and then back to your midline, and ends up at your maximum again. So just for comparison, if you were to look at the sine function, it would start here or back here. So it has just, all of the definitions are the same. The period length is, for a normal cosine function, is still 2 pi or 360 degrees. Your amplitude is still 1. For a normal cosine function, you have x-intercepts every 90 degrees. And then 180, starting at 90, sorry. They're still 180 degrees. And your domain and range are the same. Everything is the same, it's just been moved. So for example 2, we're going to graph the y equals sine x and y equals cosine x. So they're the same shape, they're just translated. So we're going to label our x-axis, and this is probably the most difficult part, knowing how to label your x-axis. So because this is a normal sine function, our period length is going to be 2 pi or 180 or 360 degrees. We're going to do it in degrees. Same with cosine. So we want to give ourselves enough room that we can see 360 degrees, so we're going to go up by 90s. It's usually good to take your 360 and divide it by 4, because there's kind of like 4 sections to each sine and cosine graph. So whenever you find your period length, divide it by 4, and that will show you an easier way to label your x-axis. So fill it in: 90 degrees, 180 degrees, 270 degrees, 360, 450, 540, 630, 720. And if you have a hard time remembering how to go up by 90s, it's just like that finger thing with the 9s. 6, 4, 5, 5, 4, 6, 3, 7, 2. You will use these a lot. Okay, now we're going to graph. So for a sine function, we start at 0. Our amplitude is 1. So our maximum point at 90 degrees will be at 1. Halfway, you get back to the midline. So half of the sine function, you should hit the midline again. The end of the sine function will be at 360. So halfway between the midpoint, you have a minimum, which is the next 90 degrees, which is at -1. Then you just do the same thing on the other side. So always just remember it's in sections of 4. So you would graph it to look like this. And it would keep going up. For the cosine function, it starts at your maximum, and it'll end at your maximum too. And halfway through you will be at your minimum. So half of a cosine function is 180. It'll hit the minimum right here. In between those points, it'll hit your midline. So it kind of looks like a V right now. Don't draw it like a V, make it curved. So there's one cycle for a cosine. So remember, starts high, hits the midline, goes to the minimum, hits the midline, goes high again. And you kind of just keep following this pattern. And if you labeled your graph right, the graphing part's easy. You just go every 2 sections. So as you can see, they look very similar. You could just shift the green a little bit to the right and they would be on top of each other. So that is the graph of a sine function and a cosine function.